I present AutoGrade, a deep learning approach towards professional trading card grading. A common practice when buying or selling trading cards is to get them professionally appraised. The largest appraisal company is Professional Sports Authenticator, or PSA for short. PSA's grading scale is correlated with a card's condition and greatly affects a card's value. PSA uses a 6-point grading criteria in determining their grades. Off-center is when the image is not perfectly center. Staining is when a card has stains. Out of focus is when the printed image is not clear. Marks is when external markings exist, and miscuts is when there are cutting errors. These 6 criteria give a card a grade on a 10-point scale. 10 is a gem mint card, 9 is mint, 8 is near mint to mint, 7 is near mint, 6 is excellent mint, 5 is excellent, 4 is very good to excellent, 3 is very good, 2 is good, and 1 is poor. PSA and other professional grading is expensive. Thus, the objective of AutoGrade is to create a system to provide estimated card grades before committing to a professional grading service. There does not exist a dataset of card images and associated grades. As such, I created a dataset of 11,500 images of baseball cards with 1,150 images per PSA grade. Since baseball cards are a popular card for grading, they were selected for this dataset. Using the online store collectors.com, images of cards and associated grades were extracted using the web scraping tool ParseHub. AutoGrade uses transfer learning with the VGG16 network. There are new layers for input and predictions. In pre-processing, AutoGrade uses data augmentation to both artificially increase the dataset size and reduce overfitting. In the data augmentation, images are subject to a random horizontal flip and rotation. The images on the right are examples of this augmentation. In the output, AutoGrade first flattens the output of VGG16. Then 2 consecutive sets of dense and dropout layers are applied. Last, a dense layer with 10 hidden units corresponding to the 10 PSA grades is applied. In the first training step, AutoGrade trains on the prediction layers for 20 epochs using sparse cross-entropy loss. On the left are graphs of loss and accuracy for these epochs. In the second training step, AutoGrade trains on the entire network for another 20 epochs with the same loss. Again, the left are graphs of loss and accuracy for these epochs. From this training, AutoGrade is able to predict card grades with around 92% accuracy. Below is a confusion matrix of the validation set predictions and some example predictions on the right. One important note is that incorrect predictions are close to the actual grade of the cards. You can find the baseball card dataset at the link below. Thank you for checking out AutoGrade.